How do we plan for ecological restoration at a watershed scale and ultimately enable successful ecological improvement in perpetuity? When we spoke last year, we spent time discussing the idea that it's not economy versus ecology. It's not ecology against economy. Both words are derived from ecos, the Greek root meaning home. There are lots of ways to define the success of a project, of course. At Trout Headwaters, we measure these quantitatively. So, for example, in dollars and cents, or in return on investment. And also ecologically. So, stem counts or bank stability indices. Local environmental markets are best understood by using a combination of GIS mapping and analysis of industry-related and environmental data. All of that, of course, in combination with project site-specific data and information. If a restoration project is intended to offset environmental impacts, for example, it's vital we understand the trends in those historic impacts or any planned future impacts. And we need to understand these down to a watershed scale. It's vital to understand local credit markets before ultimately building out a restoration site for the sake of offset or mitigation. The success of large-scale restoration and conservation projects, they rely on a toolbox full of tools, including geodesign and ecological restoration planning, long-term adaptive natural resource management, and importantly, prudent financial and property planning, the adoption, for example, of restrictive easements or covenants, and the creation of funds for long-term stewardship. Again, ecology plus economy. So welcome. Welcome to the Tye River Watershed and to the Tillman property in Virginia. The Tye River project involves some 440 acres, 6 miles of stream, and about 19 million square feet of restored buffer area. Working to understand variables in regions, habitats, environmental impacts, credit values, all of this led our firm to put 45 million environmental data points into a single relational data application. And we announced last month that much of that data will soon be available to all Esri users. So we take those ecological functions and we add to those a set of goals for each project. Goals like cost effectiveness. Are the approaches we're using going to be scalable? Do they provide for predictable outcomes? Can we meet the strictest regulatory compliance? Are we being scientifically rigorous? Choosing the proper mitigation bank site is often the most critical aspect of the whole mitigation process, and it involves several complex issues such as, what watershed is this site in? What core district does it occur in? What's the current ecological status or condition? Can we obtain authorization from the U.S. Army Corps of Engineers and the Interagency Review Team, or IRT? As you all know, our world has finite renewable resources, and we've clearly stretched and continue to strain this band too tight. We're moving past the tipping point, science tells us. So critically here on Tye River, the project focuses on streams and channel-associated wetlands, as well as riparian forests and wildlife habitats. Much of this area is a carbon sink, a vital way to sequester carbon in the ground in our fight against this changing climate. So what we have done here on every acre or partial acre available is to work to optimize ecological functions for the benefit of nature. With that introduction, let me tell you a bit about why and kind of how our team approaches this work, a process for design build to streams, wetlands, shorelines, and habitats. Restoration design at THI uses geodesign strategies in a wide range of applications. For example, watershed scale modeling of hydrology and land use. We understand that on this project, the drainage area for the bank site is something over 30,000 acres. Riparian buffer design and layout. Since we have more than 100,000 plants going to ground here, it's vital to understand those placements. The palette for the vegetation. We are consistently working to improve, to increase biodiversity. So here we're using a very diverse plant palette, probably something north of 50 species in each individual planting. And stream channel restoration, active work on something over 25,000 linear feet of streams. To date, 57,000 new wetland and riparian forbs, shrubs, and trees have been planted on the site just in the last couple of years. And in addition, stream restoration, as I mentioned, is ongoing. We'll add an additional 75,000 new stems, all aimed at restoring those buffer areas, those riparian areas, and over the next several years. Monitoring, of course, is the vital feedback loop that ensures project success and enables smart, adaptive, and iterative project design and management. So over just the past couple of years, we've collected some 8,000 data cells, and the idea then is to blend those into that adaptive management, to consider those as we continue design going forward. That strategy, our strategy for now more than 25 years, has been to jumpstart nature's process of renewal and repair. Simply, we do this by removing disturbances, human-caused disturbances, by reducing impacts, by restarting native plant communities, by that prudent management I've been mentioning, giving her those basic building blocks and allowing natural development to occur. Well, it probably sounds a little too simple and maybe even trite. If you build it, they will come. So in short, this is the work we're doing. It's all connected to our hydrology cycle, to our climate, and with the changing climate now gaining a strong foothold in our collective consciousness with the announcement of the president's new climate priorities. It's clear that our natural resources, struggling and increasingly fragile, have become increasingly at risk. And because of this, our businesses, our communities, our ecos, that is our homes, are too at risk. Restored resources are more resilient. They're more resistant to extreme weather. In restoration planning, we look to reduce flooding. We look to restore those buffers and those floodplain areas so that they sequester carbon and they slow water. We design those new forested riparian areas to filter, clean, and store water. But wait, there's more. Lisa?
The challenges of the changing environment at Tye River, increased drought, flooding, hurricanes, and other natural disasters could alone seem overwhelming. But there's also a challenging human environment, and this too is sometimes subject to unexpected changes. Despite the fact that restoration is environmentally beneficial, it is surprisingly regulated, and those regulatory and policy environments are ever-changing. Data helps to turn our ideas and insights into thoughtful, resilient designs. We need to be able to see the data in different forms, view its position in the landscape, all while ensuring a successful restoration project at Tye River. For collaboration and connection, environmental data analysis informs many of the decisions we need to make before, during, and even after the close of a mitigation restoration project. Working to understand the many variables on the landscape and economic values for Tye River, our team put some 45 million environmental data points into a platform we built called EcoBlu Analyst. And now, as a partner with Esri, we are in the process of migrating the EcoBlu Analyst system into the Esri platform to extend its use to Esri customers and others. The following processes are examples of how geodesign will enable successful ecological restoration for Tye River. Advanced mapping prior to going to ground on the site saves time and increases efficiency. Watershed and hydrologic modeling was conducted to determine flows and floodplain inundation at various flood stages and informed our decisions surrounding stream habitat structure sizes and quantities. Some of the property streams have been historically altered by incision and vegetation removal from past land uses of silviculture and agriculture. So tying in stream cross-sections, depths, and volumes assists with restoration and realignment of those stream channels and reconnection to their floodplains. Regulatory compliance requirements are generally quite rigid for this work. The specific permit application and its exhibits, including the title work, the maps, models, restoration plans, property protections, and more, totaled some 1,100 pages for this single effort at Tye River. Restoration design for the Tye River project uses geolocation data and geoplanning in a wide range of applications. For example, Explorer and Collector apps, ArcGIS Desktop, Pro, and Online, AutoCAD Civil 3D, big data analysis systems and software, and Office 365. Restoration planning, as Mike mentioned, was specific to this individual project's goals, baseline conditions, and target ecological functions. This project's chief goal is ecological improvement of streams and riparian buffers. And that improvement, or ecological lift, creates economic opportunities. The economic lift is creation of environmental credits, which can be traded in the mitigation market. These credits, in the case of Tye River, stream and riparian credits, offset unavoidable impacts to similar resources elsewhere in the watershed and are regulated by state and federal agencies. Bank owner Shannon Tillman utilizes ArcExplorer in the field to plan, monitor, inspect, and maintain site access, implement livestock exclusion fence repair, and take many other site observations. To date, monitoring at Tye River, Trout Headwaters has collected, processed, analyzed, and reviewed more than 8,000 pieces of monitoring data to validate ecological performance metrics. And to date, the data shows us that we have exceeded performance criteria for the site. Here's an example of the results for one of the restored riparian buffers on Tye River. In the Creek 3 buffer, monitoring results showed increased diversity in saplings, and the herbaceous layer showed high species richness, with over 40 species cataloged, 12 of which were species newly documented in this buffer. Invasive species were no longer prevalent in the Creek 3 buffer. Plant survivability was nearly 75% for this phase of plantings, and stem counts were up to 8,500 per acre. Across the entire extent of restored buffers at Tye River, herbaceous plots had a minimum of 60% coverage, exceeding the performance metric of 50% coverage. Additionally, survival rates of plantings continue to exceed 80%. While active restoration is part of this project, informed adaptive resource management is and always will be the silver bullet for successful ecological restoration. This is especially true as our climate changes more rapidly. No manner of active restoration will survive or succeed without it. Future priorities must marry our ecology and our economy. The priority should be to find the most cost-effective, successful techniques, apply those to the most at-risk resources, and ideally increase the success and, over time, the incentives for restoration. And maybe if we do this, and we do it right, the presently endangered spiny mussels and the many other at-risk species of the Tye watershed will return to inhabit its waters. Monitoring and adaptive management are built into this project, and in perpetuity protections for this site will help to ensure its long-term success. Mr. Tillman has established a non-wasting endowment specifically for this purpose. It's about forever or longer. Next, I'd like to introduce Shannon Tillman, owner of the Tye River Mitigation Bank.
Thank you, Lisa. Ensuring the protection of all buffers of the mitigation bank site required the installation of over 81,000 linear feet of fencing. And that's just the beginning. Stream fencing is an ongoing process for the bank site and must constantly be maintained. ArcExplorer allows us to identify and mark damaged areas electronically so we can quickly deploy a team to that location for repair work. ArcExplorer also allows us to build our buffer fences in the right location to start with. We can input our buffer survey directly into ArcExplorer. This way we know precisely where to place the fence lines so that we properly protect the buffers while not giving up any more cattle pasture than necessary. Some of the worst effects that noxious weeds have on ecosystems are that they outcompete native plants, reduce overall biodiversity in the vicinity, and can reduce the forage quality for native wildlife by up to 90%. Having a statewide baseline weed inventory in Explorer not only helps gauge the progress made in the reduction and spread of weeds on the Tye River Mitigation Bank, it also allows for rapid implementation of weed management efforts on the site during the active phase of the bank. And it will also serve the long-term stewards of the bank after closure. Thank you all for having us. Thanks to Esri, and thanks especially to Ryan Perkle and Daniel Martin. Thank you.